All right, hello pre-cal. This is lesson 7.8, the last lesson of the unit. Yay! So test coming up soon. Make sure you're prepared. Make sure you're going to get the review done. Create a problem log. We have more trig equations, and today we're solving these trig equations using regular algebra techniques like factoring, and also we're going to be doing some substitutions with our formulas as well. So there's a reason we learned the sum and difference formulas and the double angle formulas, not to mention our Pythagorean identities. So we're going to encompass all of those things we've been studying all in one. So let's see. Let's just go ahead and try some. We are going to use our calculators, and today's equations, for some reason, Delta Math is making us use degrees. So you can see we want to solve for angles between 0 and 360 degrees. So now we're using degrees. So the first thing we want to do, because we're going to use our calculators in combo, we want to make sure that we're in degree mode. Now when you're done, you want to make sure that you change it back. Okay, so usually we want to be in radian mode. So you have to understand, because this is saying we want the angles for our angles in degrees, we need to be in degree mode. So I want to change my mode on my calculator. I'm going to make sure that I'm in degree mode. And then on my Casio, I'm in the graphing menu, and I'm going to go to the setup. So again, shift and setup. And then if you scroll down, you'll see that we get to the angle. And right here, you have it's in radian mode, and you can see degree, radians, and I have no idea what GRA is, but we want to press F1, and it'll change it to degrees. And that's really important, so make sure you're in degree mode, and then make sure you change it back after today's lesson, okay? All right, so that's in degree, and we can quit. Okay. So we are solving these equations, and you'll notice we have tangent of theta and tangent of theta. We want to collect those on one side. So I'm going to go ahead and subtract 2 tangent of theta. So we collect the like terms. That's what it is. They're like terms. 9 tangents of theta minus 2 tangents of theta is 7 tangents of theta. Plus 13 equals 6. Let's move the 13 over, shall we? So 7 tangents of theta equals 6 minus 13 is negative 7. And we can divide. So this seems very similar to what we were doing before. And we get negative 1. So here we've isolated our trig function. And this is where we're going to go to our calculators. And the easiest, it's the easiest way to do this. So I will alternate calculators today. We're going to go ahead and just put the left side in y1 and the right side in y2 so that we can solve these easily. And I'm using, x. This just is the variable, whatever the variable happens to be. And negative 1. Now, what we want to do is we want to change our viewing window on both calculators. So change the viewing window because we need to go from 0 degrees to 360 degrees for our independent variable, in this case, theta. It doesn't matter what you count by, but we could say 45 degrees if you wanted to. And I think going from negative 2 to 2 is fine. Since my value here is negative 1, that's in the appropriate range. So change your viewing window, and then you can graph it. And you guys haven't really seen what the tangent function looks like. This is the tangent function. It's sort of a stretched up, tall sort of function. It has vertical asymptotes, and you can see that we have 2 points of intersection. So what we actually need to do is calculate the intersection. And we're going to use our calculate menu, or on the Casio G solve menu. Really easy on the Casio. So we're going to go, the calculate menu is here in blue. So we're going to do second calculate and go down to intersect. So number 5. And then what we want to do is simply, I'm going to use the down arrow so I can get to the straight line, and then move Tinkerbell move Tinkerbell to that point of intersection, and it's asking, is this the first curve where it intersects? And you say enter, yes. Second curve, yes. Third, guess, yes. Enter, enter, enter. And it tells you the intersection is where x is equal to 135. And that would be 135 degrees, right? Because we're in degree mode. We also need to find this other intersection. So second, calculate number 5. And I'm going to move Tinkerbell along the line to get to the next intersection. On the Casio, it's so much easier. All you have to do is press graphing solve and then intersect and then arrow right, and it'll give you the next intersection. It's so easy. And then 315 degrees is the second solution. And so those are our two solutions. I think in, I would also like to point out that 315 minus 135, they differ by 180 degrees. So if you get the first one, you can add 180. That works sometimes. All right, let's try another one. So again, our goal is to isolate the trig function. So I'm going to start by adding 4. So I have 3 secant of theta is equal to 4. And then I can go ahead and divide by 3. So secant of theta is equal to 4/3. Now, I don't have a secant button on my calculator. So I'm going to take the reciprocal of both sides. So the reciprocal of secant is cosine. The reciprocal of 4/3 is 3/4. We can flip both sides. And now this is what I can put into my calculator. So in y1 and y2. So I'm going to go ahead and delete that equation. So we're going to type in the cosine of my variable is equal to 3/4. And I'm going to change my viewing window so that we're in the right interval. We want to be from 0 to 360 for my independent variable. And we'll count by 45, so that's the scale. And then for my y, oops, I don't know why I did that. My y min and y max, -1 to 1 is actually fine. We're going to go -2 to 2, though. All right, and draw. So there's our cosine curve, and here we have our 2 intersections. So on the TI, you do second calculate the intersections. And this is such a useful tool using your calculator. On the Casio, you see G solve right here, and it's yellow. So we're going to do Shift G solve, and all I want is intersect, ISCT. So if you press intersect, it just gives you x equals 41.4 degrees. I think in Delta Math, they say round to the nearest tenth. And the nice thing is all you have to do is arrow to the right, and it's going to jump to the next intersection. It's so amazing. And then 318.6 degrees. And those are our 2 intersections. You see those did not differ by 180. That's specific to tangent. So very cool using the intersect feature. And that works for all kinds of equations. Anytime you have an equation, left side ny1, right side ny2. And the Delta Math explanation is way different. So I encourage you to keep watching these videos. All right. You'll notice here we have something squared minus 9 something plus 20. Well, this is quadratic. It's being squared. This problem is exactly the same as solving x squared minus 9x plus 20. Do you see how they are similar? This we would solve by double bubbling. Guess what? We do the same thing here. So it is 1, 2, 3 terms. So double bubble to solve, okay? So we're going to double bubble equals 0. What times what is cosecant squared? Cosecant theta times cosecant theta is cosecant squared theta. Just like x times x is x squared. What times what is cosecant squared? Cosecant times cosecant is cosecant squared. And then last times last has to be positive 20. What times what is positive 20? Negative 5 times negative 4 would be positive 20. How do we know if we did it right? We check the rainbow, of course, and you can see we'd get negative 4 cosecant theta and negative 5 cosecant theta, which gives me that middle term, negative 9 cosecant theta. So it is just like factoring with algebra. And now we're going to set each bubble equal to 0. Cosecant theta, minus 5 equals 0. And cosecant theta minus 4 equals 0. And then we can go ahead and, again, isolate the trig function. So cosecant theta equals 5. But I don't have a cosecant button on my calculator. So once again, I need to do the reciprocal of both sides. So the reciprocal of cosecant is the sine function. And the reciprocal of 5 is 1/5. We're just flipping the fraction. All right, now we're at a point where we can go to our calculator. Left side in y1, right side in y2. I'll do that. Actually, I'll just do it now. So we're going to go ahead and put sine of x in y1 and 1/5 in y2. And my window should be pretty well set up. 0 to 360 still. And find the intersection. There we go. There's an intersection right there and an intersection here. So I'm going to go second, calculate the intersection. And I'm going to move Tinkerbell up to my line, my horizontal line, because that's faster to move along. And then move Tinkerbell right to where we think the intersection is and do enter, 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 enter. So we get theta equals 11.5 degrees. Don't forget the degree symbol. If it's not there, it means radians and it's wrong. And I'm going to second calculate the next intersection. So again, jump. Move Tinkerbell to that horizontal line and then enter, enter, enter. And we get 168.5 degrees. So that's the intersection for this first bubble. But we also have cosecant of theta is equal to 4. And when I reciprocal, the reciprocal of cosecant is sine, and the reciprocal of 4 is 1/4. So once again, I can put and calculate these. Sine of x, oops, that's not what I wanted to do, equals 1/4. There we go. Draw again, my window's set up. Graphing solve, calculate the intersection, and that gives you right away 47, so that'd be 14.5 degrees. And then arrow right, and it gives you the next one. 165.5 degrees. So there are 4 solutions here for this function. All right, let's try one more. Here we have 2 terms, but you can see this is being squared. This is the same as 2x squared minus x is equal to 0. How would we solve something like this? There's just 2 terms, but they have something in common. What do they have in common? They have an x. They each have an x. Well, this is the same idea. This has a greatest common factor. So what we're going to do is take out the cosine function. So I'm going to move that cosine of x out in front, and it leaves something behind. It leaves 2 cosine of theta minus 1. How do we know we did it right? When we do a greatest common factor, all we're doing is undistributing. So we can check by distributing. Cosine of x times, that should be cosine of theta. Cosine of theta times 2 cosine of theta would be 2 cosine squared theta. Cosine of theta times -1 would be negative cosine of theta. So you can always check by distributing. And then same thing, we're going to set each bubble, I don't know what I'm writing, but I meant to write cosine of theta equal to 0. And 2 cosine of theta minus 1 equal to 0. Set each bubble equal to 0. Well, this I can plug into my calculator. In fact, that's an easy unit circle problem. Where does the cosine have a value of 0? Right here at the ordered pair 0, 1, and right here at the ordered pair 0, -1. Cosine is 0. That would be at 90 degrees and 270 degrees. Could you use a calculator? Yes, you could, but that one's an easy one. Here we want to isolate the cosine function, so that's going to be cosine of theta equals, add the 1, divide by the 2. This again, I could use my calculator, but I happen to know this one as well. 1/2 is a unit circle number. So cosine at 1/2, that's this little short x distance. Right here, that's a 60-degree angle that has the 1/2 in the cosine slot. But let's go ahead and use a calculator so you can see it. Delete. Okay, so we want to do cosine of our angle. Whoops. Cosine of x, and then we want to know where it's equal to 1/2. And again, we can calculate the intersection. So calculate the intersection, and we get, there's our 60 degrees right there. That's only the first one. So the other one is this angle down here, which I think is 300. This is 270, so that's 300. Let's see. So if I move over, there it is at 300 degrees. So sometimes you can use your unit circle to help as well. So this was the other one where we had a friendly angle of 1/2, or measurement, friendly measurement. Again, 4 solutions for that. All right, got a couple more. This is probably a little bit longer lesson. Oh, just 2 more. Let's see. We might be able to make it. What do you see going on with this problem? First I noticed I've got something squared, but I have a big hot mess. And so I really want to combine like terms, if I can. So I see I have a 2 cosines of theta and a 7 cosine of theta. So I want to move everything to one side. So I'm going to subtract 7 cosines of theta. So they're on the same side. I'm also going to go ahead and add 4. So I can add those like terms and move everything onto one side. -3 sine squared theta. Oh, I don't really like that. Why don't I like it? It's negative in front. I don't like that at all. Okay, 2 minus 7 is -5 cosines of theta. -3 plus 4 is +1. It's all equal to 0. What's the problem here? We have mixed functions. No, we can't have sines and cosines. It doesn't usually work. There is one way that it does, which I think we'll see in just a minute. No, probably not. But usually we can't have mixed functions like this. So we have to do a trig substitution. Substitute so that we have only one trig function, if we can. So let's see. When I see something being squared, I'm automatically going to my Pythagorean identities. So I want to do something to replace that sine squared function. And so I'm thinking, what Pythagorean identity has sine squared in it? Yeah, cosine squared theta plus sine squared theta is equal to 1. That's my Pythagorean identity. So what can I replace sine squared theta with? Move over the other term. Sine squared theta is equal to 1 minus cosine squared theta. So I can replace sine squared theta with 1 minus cosine squared theta. Now there's a 3 in front. In fact, there's a -3 in front. So we need to make sure that we multiply that -3 to that whole substitution. So I'm going to go ahead and distribute. That gives me -3. -3 times negative cosine squared would be +3 cosine squared theta, which is good. I have some like terms I can combine again. So I have 3 cosine squared theta minus 5 cosine theta. -3 and a 1 would be -2. This is a trinomial, so we're going to go ahead and double bubble, just like we did on the previous one. So what times what gives me 3 cosine squared? 3 cosine theta times 1 cosine theta gives me 3 cosine squared. And what times what gives me -2? -2 times 1 or -1 times 2. Those are our only options. Which one do we want? I think I'm going to put the -2 on the outside and the +1 on the inside. How do you know if you did it right? You check the rainbow. So make sure you double check your rainbow. When we multiply the outside function here, 3 cosine theta times -2 gives me -6 cosine theta. And 1 times cosine theta is cosine theta. So -6 cosines plus 1 cosine gives me my -5 cosine theta. And now I can set each bubble equal to 0. So 3 cosine theta plus 1 equals 0, and cosine theta minus 2 equals 0. So I'm going to isolate my trig function. Where does cosine of an angle equal 2? And here we have where does cosine of an angle equal -1/3? Both things that I can plug into my calculator. So we're going to calculate the intersections. Again, we're still in degrees from 0 to 360. I'm going to use the Casio. So much better. All right. Exit, clear. Oh, that one's fine. We're going to put -1/3 in my Y2 and draw. And then if I calculate the intersection, I'm going to get 109.5, rounding up, 109.5 degrees. Arrow over. Our second intersection spot right there is 250.5 degrees. So 2 solutions for that angle. And then over here, I'm going to go back and change that function to a 2 and graph it. Oh, this is an interesting one. Look, here's y equals 2 way up above. And my cosine curve, which just oscillates between 1 and -1. Are they ever intersecting? No, that one doesn't have any solutions. No solutions. I didn't spell solution right at all, did I? There are no solutions here because cosine goes between 1 and -1, and 2 is out of range. It's too big. So no intersections. That doesn't have any solutions. So we just have these 2 possible solutions. Very cool. All right, let's try one more. I'm going to try and burn rubber through this one, so feel free to pause the video. What I want you to pay attention to here is that you'll notice we have cosine of a double angle. And these are cosine of a regular angle. So again, we're sort of mixing things, and that's not okay. So I need to do, first I'm going to go ahead and do some cleanup. So I'm going to go ahead and move everything over. So I have, I'm going to subtract cosine of theta, 1 cosine of theta, and I'm going to subtract 1. So that everything's equal to 0. -2 cosine of a double angle. 9 minus 1 is 8 cosines of theta, and 4 minus 1 is 3. Now, I have to do something. I have to substitute my double angle. Cosine of twice an angle had a few substitutions, a few to choose from. And if I go back to those notes, you can have that capability as well. There were 3 different choices. This one has cosine and sine. I'd really like to only stick because all my other functions here are just cosine. So I want to use cosines. I don't want to use this one because it involves sine. Here, I want to use this one, 2 cosine squared theta minus 1. So I'm going to do that substitution so that my functions are all just cosine. So if we can write it with just 1, that's the best thing. So I'm going to trade out cosine of 2 theta for 2 cosine squared. So that's 2 cosine squared theta minus 1. And remember, that's being multiplied by -2. So I need to remember to distribute that -2. That's going to give me -4 cosine squared theta. -2 times -1 is +2. Plus 8 cosine of theta plus 3 equals 0. Oh, I don't like a leading negative. We'll deal with it. Plus 8 cosine of theta, and then 2 plus 3 is 5. So combining my like terms again. This has a negative out in front. Yuck. I don't like that. I'm going to go ahead and divide everything by a negative to get rid of it. Cosine squared theta minus 8 cosine theta minus 5. 0 divided by any number is still just 0. So that's, still have a 4 in front. Okay, same thing, double bubble. What times what is 4 cosine of theta? 4 cosine squared theta. 2 cosine of theta times 2 cosine of theta is 4 cosine squared theta. And then what times what is -5? Not many choices there. -5 times 1 or -1 times 5. I think I want the -5 on the outside and the +1 on the inside. Check the rainbow. -10 cosine of theta and 2 cosine of theta gives me -8 cosines of theta. So we did it right. Then I get to set each bubble equal to 0. So 2 cosine of theta plus 1 equals 0. And I can isolate that. So that's going to be cosine of theta equals -1/2. Over here, I have 2 cosine of theta minus 5 equals 0. And again, isolate my trig function. That'd give me +5/2. Now, if we think back to the graphs here, cosine oscillates between +1 and -1. 5/2 is way up here at 2.5. There is no solution for this particular bubble. But over here, we definitely have a solution. So I'm going to go ahead and go back to my graph and type in -1/2 for y2 and graph it. Find that intersection. Calculate the intersection. And we get theta is 120 degrees. Move over, do it again, and 240 degrees. So those are our solutions for the angle. So really cool. Enjoy this. Use your calculator and make sure you go back to radian mode. What mode should you be in? Radians or degrees? All right. Make sure you switch back to radian mode in the setup or mode menu. Folks, let me know if you have any questions. I'm here to help. Have a great day.